Hey, welcome back, everyone. So with me, I now have Uberto Barbini, and Uberto is a polyglot programmer, which I think means that you speak multiple languages, right?
Yes.
Yeah, he's a software architect with more than 20 years of experience designing and building successful software products in many, many industries. And he's both passionate and opinionated about how to deliver value to the business. Not only once, he says, but at a regular pace, which we'll see what you can tell us about it. So he's very interested in functional programming and distributed computing. And to that extent, he's also currently writing a book about pragmatic functional Kotlin. I hope you can tell us more about that in your talk. So if you're ready, Uberto?
Yes, sure.
Okay, then take it away.
Okay. Hello, everybody. With a great introduction. So today we'll talk about a bit something about acceptance test. And what I'm talking about is something that is not something theoretical, but something that we are using in production for more than 1 year. And this is the direction that basically we are going through. And having this experience forced me kind of to bit of clean up our code base and try to present as an open source project, so also other teams can benefit from our experience and maybe contribute to have a kind of better future. So let's go directly in the core of this talk. But I needed to do a premise. The whole point of this talk is based on a premise that is we have an external quality and internal quality in our code base. I'm talking about programmers and people who actually write the software. And the external quality is what everybody is looking at and everybody can see. And it's not easy to instead to see the internal quality. But one is the expression of the other. So we cannot have an external quality without an internal quality. At least this is my opinion. You may disagree, but for this talk, this is what is the base premise of this talk. And the other thing that we found is that we needed to switch our brain from this kind of idea of a cost of equality, that having equality has a cost. So we needed to kind of find this kind of graph for the optimal quality level. So let's be a bit pragmatical, not much quality. Instead, something different, something that there is a great book about quality is free. So the price of not meeting our quality standard. And not meeting the quality standard can be much more costlier than not having a good quality, not putting a good quality in place. And this the problem is that once we have a good quality, it's not that expensive to keep the quality high. But when the quality goes down, it can be very expensive. So this is a kind of a premise, what we are going to talk. And this is the reason why when we do our application, we use something that is called hexagonal architecture, which is quite known and famous standard. But in some places, they say that is too expensive to use this hexagonal architecture pattern. What we found is that it can be a bit of investment at the beginning, but it definitely pay off with progressing. And when we are doing microservice, basically our hexagonal architecture became a bit more complicated, but also kind of nicer, because each microservice basically is talking with the other microservice using this kind of architecture, where basically our domain stay in the application in the green part. That will be our model, our domain. And inside the green part, we only have a functional pure code that only care about actual requirement for business. instead, in the adapter part, in the gray area, there are all the technical implementation that we needed to speak with the HTTP, to send email, to read from message bus. And those are clearly very important, but they shouldn't mix up with the logic. So we want our application logic to be completely independent on the technical details. So if we needed to change the technical implementation, that shouldn't reflect on a change of the logic. If we change the logic, that shouldn't impact the technical implementation. This is basically the idea behind the hexagonal architecture, and it's working very well for us, and it allows us to develop microservice reasonably quick and keep changing the system. But we have a bit of a problem on the test, and so I wanted to basically talk about our journey. This idea when approaching test, this test pyramids, where basically you have a unit test, component test, integration test, and so on. And the unit tests are more cheap, basically, to write. And as we go up to the pyramid, the test became more heavy, taking time, and so we try to have a less test of the top layers. And especially the last one, the manual test, should be something that we only wanted to use for explorer test, not to actually test a regression. But even if this pyramid is correct, there's nothing wrong here. It can be a bit misleading because it can give the idea that we want to start with unit test and then going up and up. But what really we want to do instead is starting from the acceptance test. So starting from the top layer of the pyramids, and then write the test to define our business requirement, and then start writing the code after we define what are our business requirements. And this is basically what has been written in this book. That is a book of 10 years ago, but is clearly not yet widely adopted by the industry. So this idea to write the business test, the acceptance test, before writing the actual code. And the strategy driven in this book was basically this idea that we do define what is our acceptance criteria for our story. And then we start writing the story, so that if it is not clear what we should do, we shouldn't write the code, basically, until we clarify. This is not meaning a big analysis up front, but for each small story, even a small feature, it should be clear what the feature should look like before we start writing. Now the problem is how we can write this acceptance test. And one of probably the main framework in the industry is called a Cucumber, and they write the test something like this, which seems quite reasonable, and it reads very well. The problem if you have to use this is this is a bit of a trick, because it's using text and regex to translate this free text in code. So you can finish with some text that it reads very well, but then it's a kind of it's implemented in a different way that you don't expect. Also, the problem is that this test is really concerned with the details of the UI, and this is not something that we want. We wanted to say something. Scenario adding a sub page should be that something that I just added the sub page and I can see the sub page. Of course, this is not Cucumber. You can write the style, but this is what we want to do. Another tool that we play with is called Serenity, which is a bit less famous, but is still quite widely used. And Serenity add basically is kind of DSL, so you can, instead of using text regex, you can kind of write the code that looks like. Now, the problem that we had with this is that this is a kind of simple hello world. With the real case, the exception became this should stuff became quite long, and at the end you cannot really read the test anymore. It becomes very hard to understand what is going tested. So we decided basically to use another approach. And also this approach will try to solve another problem that nothing of these two frameworks are using. So this is an idea of Nat Price, that was the guy who wrote the book that I was talking before, and was working as architect in our team. And basically, this idea is to have a subtest that describe a use case, and then we run this test twice. The first time we run the test only using the hub, so only using our hexagonal internal domain without using any adapter, any external layer. And doing this will give us the confidence that the actual logic stay in the domain and the logic is solid. The second time, so the first time we ran the test only using the domain. The second time we ran the test doing end-to-end. So in this case, we will actually run the microservice. We start the microservice, so we connect to environment where the microservices are running. And then we do the actual HTTP call, HTML parsing, or whatever is needed to verify that the system works end-to-end. And this will give us the final confidence that we are releasing in production something that actually works. So it's a kind of a double-pronged approach. So we have in-memory that give us that the logic is correctly modeled in the domain, and then the HTTP layer, so end-to-end is working. And then we can run multiple times the same test. So we needed to express this idea in a kind of way that is not dependent on the UI details, but it really depends on how the domain works. And to do this, we also wanted to kind of hide the specific expectation and then let the test speak on higher level. We will see some example very soon. But what are the main benefits of this approach is that, as I said, we can verify that the stuff works at the end, which is probably the most important. But it's also useful to document the feature, because reading the test should be something that really help people to understand what is supposed to work. So it should be really close how they document. We also ensure that there is no business logic in the infrastructure layer, and that there are no infrastructure detail in the business logic. So it shouldn't be something that depends on the JSON format or on the HTTP protocols inside our domain logic. And this is how we operate, basically. First, we go to the BA, to the business. We say something, we need to do this stuff. And then we write the DDT, this domain-driven test, to capture the idea. We implement the external adapter part, so we know more or less what we need to do. And then when we arrive at some point that we need to do the actual logic, we define the model only at that point. Once we have defined the logic, the in-memory DTD should pass, because it's only using the domain. And if everything is correct, it should also pass the HTTP test. Otherwise, we close if there are some gaps. But that's usually the case, but it's quite straightforward. So we have this process that we go down and then we go up again. Basically, after having this for more than 1 year, I came out to clean up a bit of our code base and put on GitHub as an open source project. So this is if you go on, Right? On GitHub, you can see this pesticide because it's a DDT test. So pesticide seems a good name. And you can have a play with that. We are using Kotlin, our main language, but this stuff will also work with Java. As you can see, there is example Java. And this is how the test code will look like. For example, I try to model the Little Hiding Hood story. I don't know, maybe for this conference, I should have tried with Alice in Wonderland, but so far, so good. And we define the steps that happen, and we define the expectation with the settings, basically. So the kind of metaphor here is the theater scenario metaphor. And here in the top, we specify how many interpreters for the domain we are using. So we can see this is only for in-memory one, or this also using the HTTP one. But the main idea is that we have this actor. So we have, in this case, two actors, a human and the wolf, and the interaction between these two actors and the rest of the system. If there has some kind of assertion, like the last one, to check that the basket goods are completely taken care of, we hide the exception inside the details of the actor. We don't want the specific technical exception to raise on DDT level. And this is when we run in IntelliJ, how it looks like. So the same stuff happen with all these tests. And if one test fail, that will stop there. And we also do a kind of wolf win scenario, smart girl scenario that doesn't tell the wolf where it's going to. And this is also, following the Kent-Beck example, idea that we shouldn't have a test mechanism inside our test. So in pesticide, everything is really just about what's going on. There are no distraction in the test itself. And this is a bit of the details of what we are going to do. So the domain interpreter is the interpreter that basically transforms the interaction with the domain. And then the protocols is in-memory or HTTP. And this is how the code looks like for each scenario. We needed to implement the domain and try to transform the calls between the in-memory ones and the HTTP ones. But I will go fast here because I wanted to do a bit of here code. So then we have the actor that is represent a real person interacting with the system. And all the technical, all the domain assertions should be tested inside the actor, inside the step of the actor. Sorry, I got a bit of, and then sorry, and then there's this the feature, which is basically the class of all the tests, and each test is a single scenario where we let the set up the condition and we let the actor play. There is a bit of FAQ. You can also look at the website and you see a bit of answer. And now I'll do a bit of like coding. If you have any question, anyway, this is my social network stuff. So there is a chat room in this talk, and also if you have any question later, you can ask me my blog or GitHub or Twitter. But let's try to see the test first. And so this is actually, if you wanted to start to write some question now, I can try to reply the question when I'm also showing the live coding. But this is a test on kind of a pet shop. So we have a REST API to simulate a pet shop. And first, let's try to run the test. And you can see here that is running the test first on domain only, and then on HTTP. And the test is the same. And here we have a two-actor, well, actually two-actor type, a potential buyer, and a shop assistant. And that just to clarify, this is kind of representing an actual actor in our system. So there will be different kind of user of our system. And here we are simulating that the shop assistants can actually go inside the shop. And you can see just a little things that we have this method with the dollars in the middle. And then just because when we run, the dollar sign get substituted with the actual, where it is, parrot in this case, the parameter that we pass to the test. And when we write the test, you can see that we define the test with the parameter, and then we do some technical expectation. For example, we ask the system about what are the pets, and then we check that it contains the pet that we are interested in. And here Mary tried to buy a lamb, and you can see that they check the price, and then put something in the cart, and then check that there are no more lamb for sale, and then check out. And if we go inside, we can see that also we can store the current state inside the actor. So in this specific case,
sorry, Uberto, sorry to interrupt you. I think you're sharing the wrong screen.
Oh, sorry.
Yes, I didn't realize it as well.
Oh, that's wow.
Are you able to share a different screen or move your
It's correct now?
Yes, now we can see it. Sorry, I didn't realize.
Oh, I'm sorry about I really didn't realize. Yeah, this online conference, I suppose, is a bit of a learning curve for everybody.
Definitely, we're all just figuring it out.
And okay, so I'm just showing the test again. So this is the pet shop. And okay, let's run the test again. And you can see the test, and for each test, there is the domain only and the HTTP, basically. And the test is the same, but is run twice. And we can also have run this test against the localhost environment. Also, if we have deployed in the cloud, we can run the test against the cloud. And if we double click on the test, we can directly go to a check. So if, for example, just we change a bit of an expectation when we run the test again, just to show. Oh wow, we are running the wrong test. We can see that the test here failed because the price of the hamster is different. And it's quite clear what's different here. And it's both, clearly here it's both failing on both the domain and HTTP. But if the technical problem was only on the domain, in HTTP layer, the domain will pass, but the HTTP doesn't. So that also will help us. So if we double click, basically we can go to the actual place and change the code as it was. And you can see that there are a bit of dollars. That's what I was telling before inside the method name, because this will be substituted very, very simpler with the parameter that we put in the test. And in this case, yes, this is basically we ask the system what is the price for something, and this is the technical expectation. So all the technical expectations are in the at this actor level steps. They are not in the test itself. I mean, the test express the expectation at higher level, basically, something that is human readable. What I was to say is that, yes, in some cases, this is nice. Everything is nice and good, but sometimes we need to get some data out of the system. And that's why we have also this concept of a context. So when we create a cart, for example, like try to have a web shop experience, a bit like Amazon, we get the cart, but then we need basically to store the cart ID that we get from the system attached to the context of the actor. So in the next step, the actor can use the context and get the value back and use this value from to do his query to the context. And then in this case, for example, checkout with pets, we verify that the pet list is exactly what we are expecting. And another thing that we can look at, now, as I said, if you are in Java, there is also the Java example, which you know, there are semicolons, so it's Java. It's a bit not as nice as a DSL, but it's still quite similar. And I also wanted to show that there are some, we can also run domain test using an actual browser. So in this case, we are going to test Google. So in going to test Google, we don't start Google clearly, but we run a virtual browser. I don't know if you see the browser, but basically it started
I see the browser.
A browser and get the result using JavaScript, basically using the actual Google. So you can also do this kind of a technical test for details. So query Google is really open a Google and then using a CSS selector on the response to verify, to click a button basically, and then to verify something else on the expected results. If there are any questions, please tell me.
Yeah, I'm checking right now. So far, there are no questions. I think that was because your explanation was so clear. So everyone knows exactly what you're talking about.
Yeah, or maybe everybody's sleeping.
Well, it is after lunch. Maybe people are tired. Yeah. But will you be around on Umbrella? So if people have questions, they can schedule one of those.
Definitely. I will be around this afternoon on Umbrella, and then
fantastic.
Yeah, Twitter or
yeah. Great. Maybe you just put on the slide again how we can reach you.
Yes, well, that's what I was trying to do. But...
Cool. Take your time. In the meantime, I just wanted to remind people that please go to Umbrella and schedule meetings with people. And even though you don't want to actually meet them, once you schedule a meeting, you would then have the possibility to chat with them. So they can decline the invitation, but leave the chat open. So if you're feeling weird about, having meetings with strangers, then that's a way for you to like ease into it. And if you don't know who to schedule a meeting with, feel free to schedule a meeting with me. And I'll either have time or no. Awesome. Okay.
Yeah, it's also, you said at the beginning, I'm kind of writing the books on the functional kotlin. So this will be one chapter of the book. So if you are interested, you can follow me on Twitter, and there will be some announcement about this.
Oh, that sounds great. Thank you. And thank you for being here today and, delighting us with,
you guys.
Yeah, of course. Cool. So we're going to go be right back at 2:45. So that's in 14 minutes with Thomas Fricke. Also super happy that he also has a Wonderland themed talk. It's Journey to Wonderland or Horror Trip to Kubernetes Security. One of those two. So tune back in about 14 minutes to find out which. Bye.